As discussed last time, all of the resources can be found on the organic chemistry section of our Google site under the 7Chem tab. I emailed you guys the link yesterday directly to this section, so you don't have to find it on the site. And also, don't forget, I assigned all of the EP tasks I wanted you to do throughout the next couple weeks about nomenclature, or the naming of organic compounds, all at once. And I saw that several of you guys have started working through that. So yesterday you should have attempted the alkanes naming portion from EP. And you can work through it at your own pace. You can work ahead if you like, but it's all there if you want to. So today we're starting with nomenclature with other functional groups. So let's open this up. And feel free to follow along if you have a device you want to open up this and follow along with the slides on your device if you're further back and you want to see a little bit in more detail. So we're going to open this up. And I've got some warm-up questions for us to do. First of all, recall that there's a few different ways we can display molecular structure, either with the condensed structural formula, the expanded structural formula that shows all the bonds between hydrogens and carbons, but that gets a bit time-consuming to draw with larger molecules. And then you have the simpler molecular formula. So my favorite preference is probably the condensed structural formula, and we'll get practice with that throughout the unit. Now there's 7 functional groups we need to know how to name. We looked at alkanes, and the ones in bold are the ones we're going to learn how to name today. So now that we know the rules for alkanes, we can apply it and name the others quite quickly. So today's focus is alkenes, alkynes, and there'll be all kinds of fun, and alcohols, and haloalkanes. Cool. So we should be able to represent these 4 functional groups we're going to learn today in a variety of different ways. And I've given you a warm-up problem to solve right there. So this is our first warm-up problem. Attempt to name it. I'm going to give you a minute. Okay, Jake, give it a go. What's the name of this one?
1-methylpropane, and then the second one is 2-methylpropane.
What are you talking about?
The one right here?
This is one molecule.
Oh, I didn't see that little phone. Never mind. Okay, so now it's 3,2,5-methyl. That looks like. No, hit that. Yeah. Hit that.
Okay, we need to slow down. You're not quite on the right track there, bud. The first step is to identify the longest carbon chain, right? So slowly, I want to see if we're quicker though. I don't want us to walk through these steps again. Just, can somebody try to tell me the name? Nathan.
Is it 2,4-dimethyl?
That's it. 2,4-dimethyl hexane. There's the name on the screen now. So the trick was I drew it in such a way that you had to think about what end of the chain should I start numbering it from left to right along the chain or from right to left. And right to left is the proper way because the methyl side groups are actually closer to the right end of that hexane chain. So in order to use our lowest number priority system, we need to start numbering our carbon chain from the right. That makes sense so far? Awesome. This is the second and last warm-up. This one's slightly more difficult.
How do you get two hydrogens on that carbon? It's connected to another hydrogen
that's
on
a
that
mistake.
side.
Thank you.
And
Yep, that's a product of me drawing this early in the morning. Yeah, that hydrogen should not be there. It should be CH, not CH2, because this would be a pentavalent carbon, and we know carbons can't have more than 4 bonds, and this one has 5. So ignore that 2. Pretend it's not there. Good observation, Nathan. I mean, I did it to test you guys, and you passed. Besides that, have we got an idea about how to name this one?
No, this one's 100%.
You want to give it one more go? Just wait maybe 10 seconds, because I see other people still jotting down what they think it might be. So I know we're nearly there, but just before we reveal the answer, we should first identify the longest carbon chain, and then look at the groups attached to that chain and figure out, what end of the chain should I start numbering that chain from in order to use the lowest numbers possible to give the address of those branches. And then we're going to make sure everything's listed in alphabetical order when it comes to those side groups. So, can we reveal the answer?
Yeah.
Jake, give it a go.
The longest carbon chain is 5, so it would be a pentane. And then if we're looking at where the closest, so they're kind of in the same place, so there would be a 2-ethyl but I'm just going to do 2,2-dimethyl 4-ethyl.
So, if you were correct, if we were to assume pentane is the longest chain, we want to make sure, as I was just saying, that
I counted the ones in
the branches should be listed alphabetically. So you said 2,2-dimethyl 4-ethyl, and let's go with that for just a minute. Obviously, the letter D in dimethyl comes before ethyl, but something I hope I mentioned last time that probably was in the notes was that the prefixes di or tri don't affect alphabetical order. They have no effect on it. It's really the M for methyl that we're looking at. The di or the tris, we don't consider them when we're alphabetically ordering these groups. So it should technically be ethyl before dimethyl, even though E in the alphabet comes after D. Does that make sense? So we're looking at the M versus the E. If we were to put them in alphabetical order, that's why the ethyl would have to be named first. So it would be like 4-ethyl, 2,2-dimethyl. But we're making an assumption that the pentane chain you're talking about is the longest chain, and it's actually not the longest chain, which affects our whole naming of this molecule. How many carbons are actually in the longest chain of this molecule? 6. Yep, 6 looks good. Thanks, Widomu. So if 6 is our longest, and we see that there looks to be a few methyl groups attached to that chain, can somebody give me the full name? Yeah.
2,2,4 trimethylhexane.
Yeah, you got it. 2,2,4 trimethylhexane. Awesome. Kira, big smile. You got it?
Yeah.
Awesome. Sweet. That's what I like to see. Some people getting it.
Where did tri come from?
Because there are 3 of them.
Because there's 3 methyls.
Just like how we would have used dimethyl if there were 2, we use the prefix tri when there's 3 to indicate that there are 3 of them.
I'm confused. So there's the 4 that branch off the carbon. Sorry, there's the 2 that branch off the carbon.
Here.
And then
This
you
one.
get to the end of that line, and the main line turns the corner. There's a little branch off one side. That's a 3rd methyl.
Yes.
Sweet.
And that's why it's trimethyl. Tri meaning.
And if we have more than one, we have to use the prefix di or tri. You were fine with that, right? 2,2-dimethyl when we were considering the pentane being the longest chain. And that's because there's 2 methyls. Here there's 3, so we have to use the prefix tri.
Oh, right, close to the single. Right,
Yeah, cool. All right, let's move on to haloalkanes, the second of our 7 functional groups, a new one today. I kind of touched on this yesterday, that naming haloalkanes isn't too much more difficult than naming regular alkanes. And what is a haloalkane? It's basically an alkane chain where attached to it, in the place of maybe 1 or 2 hydrogens, you have some sort of halogen atom. So remember, halogens are group 17 or column 17 atoms. So we've got fluorine, chlorine, bromine, and iodine. That's what you typically see. And their name is indicated near the front or the beginning of the name of the molecule. And we use these prefixes in the table here. So bromine, if there was a bromine atom bonded to an alkane chain, we would say bromo, chloro, fluoro, or iodo, depending which of the halogens we're talking about. So here I have a depiction of fluoromethane. So just 1 carbon, hence the methane, with 1 fluorine on it. I don't need to say 1 fluoromethane, because there's only 1 carbon. There's only 1 possible carbon for it to be attached to, so it's a bit redundant to say 1 fluoromethane. You can just say fluoromethane. But here on the next one, I do need to specify what carbon the chlorine is attached to, because It could be on any of those, right? And that would create a different molecule if it was bonded to the second or a carbon. So I have to say that this is 1-chlorobutane. Notice the dash between the number and the word again. And the chlorobutane is one compound word. There's no space between chloro and butane. Same with like our methyl groups when we were learning about alkanes yesterday. And the last one is a particularly tricky one I drew up. You probably wouldn't see something like this on the exam, maybe. And I've called it 3-bromo, 2-iodo, 3-methylpentane. And you will notice that I put them in alphabetical order. B for bromo, I for iodo, M for methyl. So in that alphabetical order, that's how they are listed. So the rules are all the same. There's nothing new, really. Any questions about haloalkanes and naming them? Cool. So I'm going to put up a couple practice problems. Just like our warm-up problems, there'll be some pictures for a couple, and I just want you guys to think of the name for those. So here we are. I'll reveal the name shortly, but can we name those? Shall we give it a shot? What about the first one? Molecule on the top of the image. Maybe somebody else. Jake, I know you're keen to contribute, but you've already given me a couple. Could somebody else maybe share? Abigail, cool.
2-bromo, 1-chloropropane.
Yep, 2-bromo, 1-chloropropane. Very cool. Second one's slightly more challenging just because there's more halogens on it. It's not too complex of a molecule, we just got a few halogens to make sure that are in our name. Wait a minute, go for it. Did you say 2-dichloro?
No, fluoro.
Yeah, okay, so we have 3 fluoros, right? 3 fluorines. Yeah, we got to use that tri. So I came up with 2,2,3-trifluorobutane. It wouldn't be 2,3,3. If you started numbering from right to left, you would get 2,3,3. But we want to use the lowest numbering total possible, and 2,2,3 is a lower total. If we were to sum up those numbers, then 2,3,3. So we're numbering the chain from left to right, not right to left, to give us that lower numbering priority. Any questions about that? That's it. That's all the rules we got to use for haloalkanes. So we're on to the next one, alcohols, which aren't much more difficult either. So alcohols consist of an OH group called a hydroxyl group and it's just attached to one of the carbons, much like halogens are, methyl side chains, all that stuff. So in this table, I've got a list of very simple alcohols. So methanol, obviously having one carbon, where one of the hydrogens in methane has been replaced with that hydroxyl group to form methanol. And we have ethanol, propanol, butanol, pentanol, hexanol, and so on. And here I've got different depictions once again. So we're constantly thinking that molecules can be represented different ways, and these are all depictions of propanol. So with molecular modeling kits, the red spheres always represent oxygen, the white ones always represent hydrogen, the black spheres always represent carbons. Now, unlike halogens or methyl or alkyl side chains, when there's an alcohol in our molecule, we don't indicate that it's there at the beginning of the name. Rather, we indicate that it's there at the end of the name. So you see that with methanol, right? The OL indicating that there is an alcohol present. And we still will need to use a numbering system to indicate where that hydroxyl group is on a molecule, especially with longer chain molecules, because that OH group could be on any one of the carbons in a long carbon chain. So here are some examples. Propan 1-ol versus propan 2-ol. So the number tells us which carbon in the carbon chain that hydroxyl group is attached to. So for any alcohols containing 3 or more carbon atoms, we need to do that. So you don't need to do that for methanol or ethanol, because there's only one possible place for them to go. But 3 or more carbons, yeah, we got a number where they are at. So notice that the suffix at the end we have OL, and it's not propane OL. We've dropped the E from the alkane, so it's not propane, it's propan OL, right? So we drop the E and add the OL. We have dashes between the numbers and the words. All those rules are still the same. And once again, we'll just do a couple of quick examples because this is pretty straightforward, I think. We're all doing pretty well at this, getting the rules down. So let's give a go at these 2 molecules. I've thrown in some halogens. See if we can incorporate those rules as well. So much detail.
Kiss me, I will do it.
Give it a go. Start by drawing up that first one, identifying how many carbons are in the longest chain. And then once you've identified how many carbons are in the longest chain, we know we need to remember the position on that chain where the fluorine is and where the hydroxyl group is, right? And we know we name halogens at the beginning of the name, and at the end of the name we need to change the suffix from, well in this case 3 carbons means it's a propane, but if we're changing the end, it's propanol. So some sort of propanol, we have to indicate where the fluorine is. So with this first one, can we share a name for it? What should we name this? We're gonna move.
1,4-propan-2-ol.
Say that again. I just couldn't hear.
1,4-propan-2-ol.
Sounds good to me. 1,fluoropropan-2-ol. The next one is very tricky. You may have come up with a different answer than the person beside you, and that's because you might be wondering what end of the carbon chain to start numbering from.
Left hand.
Left hand.
Yes, that's most of the stuff is close to that.
Yeah, most of the stuff is closest to it. It's the lowest numbering priority system. Except there's a twist, and this is the final rule about alcohols. Alcohols are a big boss, and they're like, I'm more important. I have priority. So the actual answer is 3-chloro, 3-methyl butane 1-ol. They're like, I have priority. You must start numbering the carbon chain from the end closest to me. Other functional groups are like that too. They're like, no, I'm more important. You must start numbering the chain closest to me, even if that results in a numbering system where you have to use larger numbers.
Why?
Why?
Yeah, why did they do that? Why didn't they just stop all of it from one side?
It's because, as you see here, we have a few different functional groups happening. We have an OH, like an alcohol functional group, a hydroxyl. We have a halogen, right? And as you encounter molecules that are very complex and have multiple different functional groups on them, when it comes to naming them, you have to choose which of those functional groups takes priority in the name. Like some functional groups we haven't seen yet also means that we have to change the suffix of the end. So in this case, because it's an alcohol, we know the suffix has to change from butane to butanol, right? But if there's another functional group where the rule is you must apply a different suffix to the end of the word, and you're thinking, oh, but I have an alcohol, and an alcohol means I need to put that suffix at the end of the word, but I have another functional group that says I need to change the end of the word to its appropriate suffix. Which of those two do I change? Which of those two do I use in my name? Does that make sense? If there's two possibilities, and both rules say change the end of your word to the appropriate suffix to reflect the presence of that functional group, you have to choose which one is more important, which one do I actually use in the name. And so that's resulted in something called a list of priorities, which functional groups are more important and take precedence or importance in the name. So, and that also means with that comes a numbering system associated with them. So whichever functional group is most important in the name means you prioritize numbering from that functional group along the chain.
But surely if you have to make, if there was two things that changed the suffix, you do the same thing as you do with the prefix and just stick one after the other.
So I'll give you an example. There are tons of molecules that contain hydroxyl groups, which kind of makes them an alcohol, but they have a more important functional group. And when they have a more important functional group, so I'll give you an example. Something in level 3 you'll encounter a ketone. This is a ketone. This is a great learning opportunity. Okay, this is called a ketone because it has this functional group in it in the middle of the molecule. But it also has an alcohol functional group, which we're just learning about, right? So this is some sort of butane chain because there's 4 carbons in a row. So you would think, oh, this is some sort of butanol. And I just indicate out front that maybe there's like a ketone on the second carbon, right? But the ketone actually takes priority when you look at the full list of which functional groups are more important. So this is actually called a butanone. It's a ketone, and you see the suffix reflects the presence of a ketone. It takes priority in the name. And that means the hydroxyl group needs to be indicated along the carbon chain. And because the ketone takes priority, we start numbering from this end that's closest to the ketone. So this is carbon 4 over here. And so that means our hydroxyl group is on carbon 3. And when we indicate the presence of a hydroxyl group in the name of something where there's a more important functional group, we name it actually as a prefix. So this is actually 3-hydroxybutanol to reflect the presence of a hydroxyl group. So you can see the name changes when there's 2 or more possible functional groups where we have to apply a rule or an ending to the name, and we have to choose which one is most important to reflect in the name. Then all the other less important functional groups need to be reflected as prefixes in the name. That's really advanced stuff, but my point is that when you have a combination of functional groups, you have to think about which one's more important and just go with that. Okay, alkenes and alkynes are the last ones we're talking about today. I've combined them because the rules are pretty much the same. So alkenes contain at least one double covalent bond. That means they're sharing 2 pairs of electrons. Alkynes have a triple covalent bond. Now, alkenes and alkynes are both described as unsaturated because they have the capacity to accept more atoms to bond with those carbons if the double bonds were to be broken. Because, you know, a carbon can support up to 4 bonds. But if you have a double or triple bond, you've limited the capacity of that carbon to accept as many bonds as possible because it's just sharing electrons within carbons. It's very introverted, if you you want to think of it like that. But if you were to break those bonds, break it out of its little shell a little bit, get it talking to some other atoms, it would form more bonds, and it would become a saturated molecule, like an alkane is. So the suffix of the name is what's changed. So instead of like butane for an alkane, it would become butene if it was an alkene, or butine if it was an alkyne. So that's it. That's the rule. But we do need to indicate where along the carbon chain we find this double or triple bond, right? Because it can be located anywhere along the carbon chain. And we number it from the position where the double bond or triple bond starts, where it begins. Because obviously that double or triple bond occurs between two carbons. So which carbon do we number in our naming? We use the carbon closest to the end of the chain where that double or triple bond begins. And I'll show you a couple examples. So if you look up here, look closely, you have but-1-ene versus but-2-ene. So if we number the chain from left to right, from carbon 1 on the left to carbon 4 on the right, we see in the first instance, but-1-ene, the double bond occurs between the first and second carbon, so it's called but-1-ene because it begins on the first carbon. And with but-2-ene, it occurs between the second and third carbon, so we call it but-2-ene because it starts on the second carbon once again. So where it starts is where we number it from. So if we were to do a couple examples, let's look at the first one. Once again, the first one's a bit easier than the second one. So you've got a methyl branch off of a chain that contains 5 carbons, and there's a double bond. So which end of the molecule should we start naming from? One, the left side, yeah, left side. Because the double bond begins on the second carbon from the left, and there's a methyl group on the third. So that's lowest numbering. What would we call this then?
Free methyl pent-2-ene or?
Yeah, sounds good to me. 3-methyl pent-2-ene. Awesome. And lastly, last example for today before we apply this to some work. It's a bit more complex because we have some halogens in there. We have a triple bond. So it's not an alkene, it's some sort of alkyne. Any idea what we should call this one? Alex? I want somebody else. Rosa, any idea? So I'll just talk it through as we hopefully build more confidence and get more hands up. I see 2 hands up, 3 hands up. I'd like to see a bit more by the time I go through it. So there's 4 carbons in the longest chain. It's an alkyne, so it's not butane or butene. It's some sort of butine. We need to number where the triple bond starts. And I will say the triple bond takes priority, so we need to start numbering from the right end. That might be why we were a bit uncertain to commit to an answer. We start numbering from the right end because the alkyne is bossy like alcohols. They take priority. So we have halogens on the 3rd carbon then. So putting that all together and naming the halogens alphabetically, what do you think we should get? I'm still seeing 3 hands. Can we get a few more? Fine. Go for it, Nathan.
3-bromo, 3-fluoro, 1. Sorry.
You had a good start. 3-bromo, 3-fluoro is good.
3-bromo, 3-fluoro, but, 1.
Yeah. But-1-ine, just a small change there because it's an alkyne. But you nailed it. You named the halogens alphabetically, and we do put the numbering for the location or the start of the double or triple bond between the word but and ine. So it kind of squeezes in there between them. And that's the name. So that's how we learned how to name 4 different functional groups today. Alcohols and haloalkanes, and their naming occurs as prefixes in the name. And we name those halogens alphabetically. But the alcohols, we name them at the end, right? like butane 2-ol, we need to number where the hydroxyl functional group is occurring. And same with double and triple bonds. We need to indicate with a number where that double or triple bond begins in the carbon chain, and they take priority as well. So we start numbering the chain from the end closest to them. So we're going to apply that to some practice problems from our SciPad